Wild AP fish classroom performing the studies.
We're going to the fish tank, by the way. Just for the people watching at home. Mr. Burkham, why is it that your shirt is so much more vibrantly colored than in real life?
I don't know.
Is that just a camera optics thing, or?
These fish are going to be traumatized.
Are they expecting dinner?
Kind of.
Huh.
They're going to try to eat your meter stick now.
Who feeds the fish?
Like this.
Oh, that's right. They like the laser. Camden started a fish fight once.
Sounds like a very family.
You pointed the laser on the other.
I finally understand why we have fish.
Okay, so where is They like
Ah!
What have you done? Hold that for a second.
That would have been funny. The fish just like.
I'm just thinking about where I can make this thing.
Hippity hoppity, this laser's my property.
Just be taller.
Some of us have genetic disorders.
Oh, my bad. Just hit the gym.
Probably. Anyone with blue eyes does.
Yeah, hit the gym.
It's not a disorder.
A mutation.
Yes.
Well,
Not
the order
disorder.
is like green and brown eyes, so that would be a disorder.
It is.
Let me know when I can get it. Okay, there we go. It's hitting.
Oh, the
There.
All done.
go a month into AP business. All right, go play.
No, it's not.
Now it was. It was.
Sorry.
He wasn't careful.
Is the laser water?
This is a poorly lit area.
I want to know what weird looks like. Look at it straight. You can just watch it when he uploads it. What's happening now?
Why am I the one who's holding the camera? I'm sure.
I don't know.
Bruce should be the one manning the
You're always the
camera.
person that
Bruce
uses the
should be the
camera.
Oh, there we go.
I don't know why I'm doing it.
Get the
So
laser
you see that?
fish.
I'm too short
Okay.
for this.
So who's got the other?
Yeah, why are tall people in the front?
Okay.
Yeah, why are tall people in the front?
Because we're
Shine the light
discriminating.
in the water.
I want to get over here.
Okay. Now, try and so line up the edge of that
Like
where
so.
that dot is. Okay. Now bring that up to where the laser itself is. So in other words, you're going to make that be the line.
Shine it together.
Okay. Got it? Yeah. Now, so what do you notice about that angle? Does it go straight as it goes through?
No.
So what happens is that water is more optically dense. So as I want to fan this out a little bit, can you still see it?
There it is.
Okay. So notice that as I shine that light in there, when that light hits one edge, and if you think of my hand as being like a set of wheels. So as that light comes in, it's going to hit, and then this set of wheels is going to slow down first. Then, because that slows down, then it gets tilted, and it goes in like this. So if you reverse it, if you were to come here coming out, then when it hit this point, what would happen?
It would.
So the top of my hand would speed up first, and then it would get flattened out this way. So if you're going from something that's more optically dense, it hits, and then it slows down. If you reverse it, it hits, speeds up, and then goes this way. Now here's what's going to be important. We're going to get into what's known as Snell's law. So anytime you're talking about the angle, it's the angle with the normal. It isn't the angle with the water. It's only the angle with this. Got it? Got the visual? Okay, back we go.
Wait, does the density of the water also have to do with the reason why when I'm looking this way?
Oh yeah.
Whereas below the water is reflected, but up here it's
Yeah, if you've not like kind of stared at this thing through different angles, it's pretty cool. So,
Thank
Because the front and
you.
back are reflective under the water, but I don't want anyone to ever say it's
Hey, Andrew.
What?
Smile. You're on
No,
camera.
I am not being recorded.
Yes, you were.
I refuse to be recorded.
I have a sensor bar.
Very nice. Very nice.
I'm
Aaron?
not consuming a battery.
Okay.
Why? Battery actually is good for you.
All right, Josh.
Poisonous.
No.
You're
Hey,
being recorded.
did you know battery acid can fuel Death Stars?
Goodbye. Tate?
Did you know the Death Star ran on double
Tate, what?
double A battery?
Cool Tate.
Exploded when Luke shot the thing. It's
The things this class gets up to.
It's like the bottom of an Xbox controller. It's just a massive room with just lined with batteries and whoever is thinking that they have.
Mr. Bergkamp, if I were you, I would be concerned about the safety and sanity of this class.
I am concerned about the safety and the sanity of everyone around me.
Pretty much.
You know what said that the Death Star ran on double A batteries? And there was just a massive room of like the bottom of the Xbox controllers, but it's those, just a massive room of those, and you have to like, stick them all in.
Hey.
If you use them, you have to go and change them.
Hey. Hey, Andrew. Do you know what Snoke's name stands for? Since no one knew existed.
Why would I have that joke?
Where's the dad joke?
I mean,
I'm not Eric. I'm not capable of
You've seen The Last Jedi?
No.
Or
no.
I
Luke
haven't.
Skywalker?
Yes.
Yeah.
I
Well, then
haven't.
you'll know why Snow died.
I know, but his name is an acronym for Sith no one knew existed.
You know why.
No.
Okay,
I don't remember that.
so here's kind of a simple application of this concept. So let's say that you're going from air into something glass, air, whatever it is. And let's say that the index of refraction of that material is 2. So you always kind of have to look at, okay, where is this thing starting? So this light is coming in here like this, okay? And let's say that this angle is 30 degrees. All right, so this is what we're going to call this angle of incidence. So it's pretty simple. It's N1 sine theta 1 equals N2 sine theta 2. So what I want to figure out is what's going to be this angle on the other side. All right? So let's just kind of think this through. So if you look at this in terms of being like this pencil. So it's coming in like this, and this is like you're on dry pavement. This is like a muddy track. So when this thing hits, this side of my pencil is going to slow down first. It's going to tilt it like this, and then it's going to come down here like this, right? So conceptually, I got to figure that this angle is going to be less than the value of the sine, less than 30 degrees, because of the fact that it's going to bend it more towards the normal. So if I do this math and I'm trying to find this, I'm going to take N1, sine theta of 1, divided by N2, and then I'm going to take the inverse sine of all of that, okay? So I've got N1, which is 1, sine of 30, anybody know the sine of 30? 0.5. Yay, they still teach you something. And then N2 is 2. So basically I've got 0.25, I've got a half divided by 2, which gives me 0.25. And then that gets me an angle of 14.5 degrees. Okay? Okay? So this comes in at 30. It's going to be get bent down towards the normal. That's going to be an angle of 45 degrees. Now, could I calculate the speed of light within that new medium as well? All right? Because if it's 3.00 times 10 to the 8th meters per second in a vacuum, when I hit this more optically dense medium, how am I going to get the new velocity? Divided by 2. So the speed of light actually becomes
1.5 times 10.
yeah, half of what it would be in, because you're dividing by 2. So the speed of light slows down to half. Now, don't think about it too much like, what makes it slow down? It does. Just go with it. Okay? Now, what if we did this? What if we came in at, that was horrible.
Curve the light.
That was even worse.
I'm so glad I can't see through your
At
head
30
because otherwise it
degrees,
would be so,
okay?
so triggered based on what he's saying about the times.
So then it's gonna get bent down at 14.5 degrees. Okay? So let's say this is air, and let's say some type of glass. Now, when it exits the glass, then what's it gonna do?
Speed back up.
Then it's gonna hit here. This side of my hand is gonna speed up first, right? Because that's getting back on dry pavement. So then it's gonna come out like this. So if it comes in at 30, it's bent down to 14.5. Then if you were to reverse it and go, okay, hey, that's now 14.5, then when it leaves, it's gonna go back to 30. So these two lines would be parallel to each other. And it doesn't make any difference like how many, like let's say you had a layer of water in between, it would still go doink, 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 but as soon as it got out, it's still going to go back to 30 degrees. As soon as that it enters glass and then it leaves glass. So you could have a layer in between, it wouldn't make any difference. Okay, so one of the problems that you're going to have on your assignment is kind of like a trick shot. So the short version of the trick shot is that you would have a situation like this where you're going to shine a laser in and it's going to hit like a mirror and you're trying to figure out like where to shine that light where it would hit a point over here. So imagine that I've got my laser and I'm shining it at the mirror that's on that wall and I'm trying to hit the door over there. Okay? Now, here's the basic idea. What do you know about these two angles? Well, bigger idea. This angle of incidence should equal the angle of reflection, right? So, what I would do, and this will make sense once you get to this problem. How do you define, what's the ratio for tangent? No. Ratio of what you value. Okay, opposite over adjacent. So what I would do, this will make sense when you get to this problem. I look at this in terms of, you know that these two angles are going to be the same. So the tangent of this angle then has to equal the tangent of that angle. Okay? So if you can look at it in terms of like ratio, you could also look at it in terms of, it'll make sense when you get to some variables, but keep that in mind. Okay. I am done.
Yay.
Okay. But we've got questions that need to be written down.
Also the question, that equation I saw before that, so it's n1 of sine theta 1 equals n2 of sine theta 2?
We're after it right here. I can't talk about it for much. Here, get down.
Purple one? No. They do have n sine theta 1, which is not n sine.
Ryan, it's right there.
Yeah.
No, it's right there.
Oh, Derek. I do the stupid. Okay.
It's fine. We all do the stupid sometimes. I'm not aware.
We're all the
We are the stupid. No, we just all.
Or was that not bothering?
That might be what it
life.
is.
Life is the baby dog.
Okay, so on this assignment, when you get to this first question, remember kind of that demo that I did with the laser when we first started? And you couldn't see the laser until like I did the James Bond thing and hit the aerosol spray through it, okay? Keep that in mind. When you get to problems, on this problems part, Liza, only do 8A, and this is 9 through 11.
Oh, 9/11.
Okay? Otherwise known as 9, 10, and 11.
9/11.
I know that's a radical concept.
Wow.
I know.
So it's 5 through 11 minus 8.
And when you get to number 6 is the one with the trick shot. Okay?
Don't do just 5 through 7.
Huh?
Why not do 5 through 7?
Or even better, it'd be like 5 through 11, but only A on one.
I don't know, when I was writing them out, I would just kind of piecemeal it. Yeah, I could do that.
Sounds good. We'll get with this. We just
5 through 8A, how about that?
Yay!
And then 9 through 11.
On September 11th, 2022.
Y'all get the point.
Gotcha. 5
9/11 will
minus
be legal
8A.
to drink.
We accept that.
It will be legal for 9/11 to drink. Have fun with that.
Shush. I'm turning it off.
Yeah.